download the final. Okay, and then the final is due back on Friday. So you got all day Thursday and all day Friday to do the final. Now the final, the problems on the final, I found that the final problems I think are easier than the than some of the test problems that you had. Okay, so on the final, there's a problem where you have a tank mixing problem, and I'll even tell you it's a problem where the rate in is equal to the rate out. So that makes it simpler. Remember, you had a problem on one of the exams where the rate in was different than the rate out. And it turns out that you have to solve that differential equation using an integration factor, okay? So when the mixing problem, when the rate in is equal to the rate out, the rate in is equal to the rate out, you could just solve it by separation of variables, okay? And then you have to find the general solution to a differential equation and define what the interval is, identify any transit terms, and you're gonna have to figure out whether it's a separable equation or not. Okay, so that's number 2. 3 is to find the power series solution of a given differential equation. Okay, 4 is radioactive decay, a problem just like I did yesterday. Okay, radioactive decay problem just like I did yesterday. 5 is Euler's method and understanding a MATLAB script. I'll tell the people that are here, the answer to this, to 5 is in my notes. Okay, so the answer to 5 is in my notes. The plus transform problem with the unit step function. And then given a driven mass system with dampening, find the total solution and what is the steady state solution. Now, let me make this clear. It's probably not important for the people that are here. It's probably important for the people that are not here, is you must use the method of undetermined coefficients. Previously on the exam, people used the method of annihilation and also variation of parameters. We're required to learn the method of undetermined coefficients, which is the method I taught. In the past, I kind of let it go. But if you don't use the method of undetermined coefficients and you use variation of parameters or some other method, you're gonna end up with a 0. Okay. And then 8 is given a differential equation. You have to draw the phase portrait diagram, solve the differential equation, and what is the amount there for a specific period of time. I'll tell you too, number 8 is actually one of the Weber-Sign problems. It's a Weber-Sign. So if you did the problem in Weber-Sign, you already have the solution to number 8. Okay, so that's the final exam. And as always, I'm going to be grading the 4th exam. I'll be grading the 4th exam. I'll be posting the solutions. The same thing with the final. I'll grade the final exam. I'll post the solutions. And then, if you feel that I made a mistake grading your exam or I was unfair, you can send me an email and we can talk about it. I need to get in the final exams on Tuesday, next Tuesday. Okay, now here's some good news. If you go to, let me, I just want to show you something as far as MATLAB is concerned. Okay, now I was thinking about giving a MATLAB project, but I figured now at this stage of the game, you have the exam 4, you got the final. So I decided not to give you the MATLAB project. But here's a typical MATLAB project that you would have. So let me tell you about it. Is that in MATLAB, if you want to find the eigenvalues and eigenvectors using MATLAB to solve a system of differential equations, this is the script. See, it's pretty easy. You just specify the matrix. So here's a 2x2 matrix. And this is what we found yesterday. Yesterday, we found the eigenvalues and eigenvectors of this matrix here. All right. So you just define the matrix, and then you use this syntax where you want the vector and you want the matrix to be diagonalized. That's what this means, right? It turns out when you diagonalize the matrix, that is the same as the eigenvalue. So when this matrix is diagonalized, right, you get the two eigenvalues. So these are the eigenvalues. -1 and -2 is the eigenvalue. All right. So this is what we found yesterday. We found this is one of the eigenvalues, right? This is the problem that that I had you do, and then I did it, right? And then this was the other eigenvalue. And then these were the two eigenvectors. And keep in mind that the eigenvectors are not unique, right? Because C1, for example, C1 can actually be negative. And if C1 is an arbitrary constant, so is C2. So if C1 is negative, then this can actually be -1, and this could be +1, right? If C1 is negative. Let's say C1 is -1. The same thing here too. This could end up being +2. Excuse me, this could end up being +1, and this could be -2. And then also this could end up being 2, right? This could end up being -2, and this could end up being +4, right? Depending upon, so I just want you to realize that, and the C1 and the C2, right? That would actually come out when we apply initial conditions to the system of differential equations. Now, what MATLAB does is it normalizes the eigenvectors. In other words, these are the eigenvectors, right? So what MATLAB does, it actually normalizes it. All right. So in other words, when you normalize them, you would take the 1 squared and then the -1 squared and divide it by 1. And here you take the 1 squared minus the 1 squared divided by -1. So this is the normalized eigenvectors. All right. And here too, when you want to normalize this eigenvector, it would be -1 squared and then +2 squared, right? And then you divide that into -1 and you divide that into -2. So this is the normalized, eigenvectors. Now, many times the MATLAB project, which I'm not having you submit, the MATLAB project is that instead of doing a 2x2 system of differential equations, you know, a MATLAB project could be, you do a 4x4. And finding the eigenvalues of a 4x4 matrix could be very difficult. Even a 3x3, sometimes it's a lot harder to solve a cubic equation than it is to solve a quadratic equation. So, but you can use this script, right? You can easily use this script and get the eigenvalues and eigenvectors and solve a system of differential equations. Okay, but we would want to have real distinct roots, right? Because we only dealt with real distinct roots. Okay. Finally, if you go to my grades, you'll find what I gave everybody. Let's see. If you go to my grades, let's see. I think I gotta go to student mode. So when you go to my grades, you're going to find that that you got 100 for your MATLAB project. Okay. Now, once again, I want to make it very clear that the MATLAB project is worth 5% of your grade. All right. So I gave everybody 100 for the MATLAB project because we really didn't get to it. And I kind of described now what the MATLAB project, an example of what the MATLAB project would be. And if anybody does want to try to solve a system of differential equations with maybe a system that has four different differential equations. In other words, some function of x, some function of y, some function of z, and some function of w, and you use that MATLAB script, I will give you extra credit. But it always turns out that the students that don't need the extra credit get the extra credit. Okay, so probably by Monday you'll see this thing all filled out with with the grade you got on each one of the exams. Okay, your WebAssign homework grade. Now, let me just talk about that for a second. The WebAssign homework grade, it's automatically calculated by WebAssign. So depending upon, it also tells me how much time people have spent, working the WebAssign problems. So the WebAssign grade is automatically calculated. Well, finally, I did give you just one problem in 8.2. All right. So it's very similar to the problem that you have on the exam. I think it's just with different numbers, but I do want you to do the one problem I have in 8.2, and that's also due on the 21st. Okay, so a lot of students missing today. I guess they feel that it turns out that the students are missing is not. I can see the names, and the students that are missing are the ones that are not doing as well. Okay, in general.
Wait, Professor, I have a question.
Sure.
So for the verb
Can
assign,
you speak a little louder? I'm having trouble. Maybe I need to put my thing up.
for the verb assign, how is it graded? Because for the verb assign, I really try my best to like estimate.
Hold on one second. I'm having trouble hearing you.
Can you hear me now?
Yeah, I got to turn my speaker up. For some reason, my speaker's way down.
Yeah, for the verb assign.
Yes.
Because I looked at my grade, for some reason it have 81%. That's why I was kind of really shocked. So I did all the homework, and I barely I get it like almost all 100, except only like 4 of the topic that I get like a B on. But when I look at my grade, it say 81%.
Does it still say 81%?
Yeah, I check it.
Did you just hello, are you still there? Hello?
Yeah.
Okay.
Yeah, I'm still here.
Well, let me well, I could take a quick look after class and we can see what you missed. Or look what like I said, I don't calculate the WebAssign. It's calculated automatically by WebAssign. Now, the grade didn't like say for example, if you had like a 70, did you do the ones? Well, you didn't do the 8.2 yet, right? Did you do the 8.2?
I finishing everything like last night.
Oh, okay. You finished everything last night and it's still telling you 81?
Yeah.
All right, well, why don't you stay on and we'll take a look later, okay?
Okay, thank you.
Any other questions? That's if anyone has any questions, I'll stay on, but I wish you all luck on the final exam, and I wish you luck in other classes as well, of course. And I think that there's several people in this class I would really like to have an in-class. I always prefer the in-class teaching than the online teaching. I get to know the students and they get to know me better. And so that's it. So once again, I hope you enjoyed the class. I hope you learned something. That's what's the most important thing, is that you're learning. And what else? Is there anything else I need to tell you about? No, I guess that's it. And if there's any concern about your grades, do email me. And so that's it. If anybody, so that's it for today. Not only for today, but and once again, so tomorrow you'll be able to download the exam and download the final exam. It's starting at 8:30. I'll let it 8:30. And let me just go back to so if you go to week 6. Okay, you'll see that right now it's not available to you. It will be available tomorrow morning. See, it says it's hidden from the student. So this is the final exam. It'll be available tomorrow. And then I'll also have, after I grade exam 4, you'll have the solutions to exam 4. So you compare your solutions with my solutions. And then I'll also download the solutions to the final exam. So once again, you can compare your solutions with my solutions and see if I was fair or unfair. Okay, so that's it. Like I said, it was gonna be a short class today. So everybody has 100 on the MATLAB assignment. And like I said, if you want to do the MATLAB assignment where you solve a system of differential equations using the, using what I showed today, where is that? Yeah, using this here. That's normally the assignments can either be solving a system of differential equations or Euler's method is sometimes used as one of the assignments. But, it's normally something that's difficult to do manually, right? You give a problem that's difficult. Like you want it to be very precise and had a very complicated function, it would be very hard to integrate. Then you would do that using Euler's method. If you had a system, if you had a first order differential equation, it's very hard to integrate. You want to use Euler's method. And if you had a large set of systems of differential equations, you'd want to use MATLAB to find the eigenvectors and eigenvalues. Okay. So that's it. I wish everybody luck, and maybe I'll see you sometime around campus. So stay on though if you have any questions.
Thank you, Professor.
Okay, have a great day.
You too.
Thank you, Professor.
Okay, you're welcome. So let's see, let's take